Hello there. So in the past few lectures, we've discussed triangles, and in the past lecture, most specifically, we've discussed right angles. Since the sum of the angles in any triangle is 180 degrees, naturally it would follow what happens if we combine the two. What happens if there's a triangle where one of the angles is 90 degrees? And I've actually drawn one ahead of time right here. This is what is known as a right triangle. One of the angles is a right angle. We denote by this little box, which says that it's 90 degrees. Now, previously we haven't actually thought about what the lengths of the triangles are in relation to each other, and we don't really have a way to figure out if we know one of the lengths to find the relations between all three of the lengths. Well, that's about to change. We have what is known as the Pythagorean Theorem. So right here I've actually illustrated, right triangles in a specific pattern for a reason. If you notice, I have actually four of the same right triangle and a square in the middle. Now, clearly, A plus B is the side length of this big square here. So A plus B squared, or A plus B times A plus B, is going to give us the area of the whole square. And if you remember from foiling it out, that's equal to A squared plus 2AB plus B squared. Now, what if we want just the area of this middle triangle inside? Well, we can subtract off these four areas here. And what are those areas? Well, I guess we'll get to this later when we talk about area formulas, but for now, I guess you should know that the area of a triangle is A plus B divided by 2. So if there are four of them, 4 times this is actually, A times B over 2. So if we have 4 of them, then we're multiplying this by 4, and we just get 2AB. And does that seem familiar? It's this middle term right here. So the area of our C box right here is just A squared plus B squared. So what does that say? That gives us this relation. For any right triangle, and remember this only works for right triangles because of these boxes here. If those weren't here, then we wouldn't actually have a square within a square. We have the relation A squared plus B squared equals C squared, where A is this side length, B is this side length, and C is the longest side, which is called the hypotenuse, which is opposite the right angle. And remember that because this angle is 90 degrees, it's going to be the largest angle we have, regardless of what the other two angles are, because if we have a right triangle, and one of the angles is 90, remember that the sum of the angles is 180 degrees, so the sum of these two angles must be 180 minus 90, or 90 degrees, and one of the angles cannot be 0, so neither of the angles can be larger than this angle. That means that this is the side opposing the largest angle, and it's called the hypotenuse. There are very special numbers known as Pythagorean triples that are actual counting numbers like 1, 2, 3, and so on that satisfy this equation that we have right here. Some examples you'll see often are 3, 4, and 5, 6, 8, 10, 9, 12, 15, and so on and so on. I encourage you to actually explain if you see this is a multiple of this, this is a multiple of this, this is a multiple of this, and actually all of the multiples of these satisfy this relation. I encourage you to figure out why. But enough about these because there are some more. We have 5, 12, and 13, 7, 24, and 25, and 9, 40, 41, and they continue and so on and so forth. And any multiple of these is also a Pythagorean triple, which I encourage you to figure out yourself. The later ones are more challenging and are often not seen.